Let's look at some more challenging domain questions. So here's a function f of x equals root 10 minus 2x, then the radical has ended, then plus 30. This is all over x squared minus 13x plus 30. By the way, the 30s that are on top and bottom do not cancel because they're not factors, right? They're because of the plus signs. So, what do we want? We need the stuff inside the radical to be greater than or equal to 0. So the thing that would be rooted eventually would be 10 minus 2x, whatever x is. But 10 minus 2x is the thing that we're going to take the square root of. And we don't want that to be negative, so that needs to be greater than or equal to 0. We want that to be greater than or equal to 0. We also need to avoid the situation when x squared minus 13x plus 30 is equal to 0. So let's take that want inequality, add 2x to both sides, divide both sides by 2, and just switch the order this is written in. So we want x to be less than or equal to 5. Finally, regarding the denominator equaling 0, if you factor the left side, x equals 3 or equals 10. But remember that we need to avoid this. Okay, so we want x to be less than or equal to 5. However, we have to avoid x equals 3 and we have to avoid x equals 10. Here's what a picture looks like. So the numbers we want, we can include 5, but we need things that are smaller. However, we have to avoid the number 3. We have to exclude that one number here. So the domain, parenthesis negative infinity comma 3 parenthesis union parenthesis 3 comma 5 square bracket. And we're done. Though somebody might say, hey, what about 10? We've already avoided 10. Yeah, we've avoided 10 due to the fact that we want x to be less than or equal to 5. So the word want and the word avoid are really important to keep in mind here. This is why you want to write these words, want versus avoid. You should write this because they are basically opposites of each other. Let's do another one. Find the domain of f of x equals 3 plus root, and inside the root there's absolute value of 4x plus 2, closed absolute value, minus 6. So we want the contents inside the square root to be greater than or equal to 0. Let's add 6 to both sides. And then how about we do a substitution? U would be the stuff inside the absolute value. So u would equal 4x plus 2. And doing that, our problem becomes absolute value of u is greater than or equal to 6. So think about what values of u would make that work. U equals 6 would work, u equals 7 would work, u equals 8 would work. By the way, u equals negative 6 would work, u equals negative 8 would work. 0 doesn't work, right? U equals 0 doesn't work. So here's a description of what values of u work. So u is less than or equal to negative 6, or u is greater than or equal to 6. Notice there's no more absolute values here. Now that both of these inequalities have u by themselves, we can substitute 4x plus 2 in place of the u. So 4x plus 2 is less than or equal to negative 6, or 4x plus 2 is greater than or equal to 6. Subtract 2 on both sides of both inequalities, divide by 4 on both sides of both inequalities, and we have that we want x to be less than or equal to negative 2, or we want x to be greater than or equal to 1. Here's a picture of that, and here's the domain written in interval notation. In parenthesis negative infinity, comma, negative 2, square bracket, union, bracket, 1, comma, infinity, parenthesis. So this one's a little more challenging, but it's really, at least it's not mixing a want and an avoid. This one's just challenging because once you've set up the inequality, you actually have an absolute value inequality. Okay, somebody's going to maybe say, wait, something seems concerning. There's these negative numbers like negative 2. I thought you can't square root a negative. Yeah, that's right. We can't square root a negative, and we're not square rooting a negative. Okay, what we're doing is we're square rooting absolute value of 4x plus 2 minus 6. That's the thing that must be greater than or equal to 0. That's why we said that we want the thing we're rooting, okay, which is absolute value of 4x plus 2, close absolute value minus 6. It's that needs to be greater than or equal to 0. We never said that x had to be greater than or equal to 0. It's just what we root has to be greater than or equal to 0. This just happens to occur when x is either in this first interval or in the next interval. So as long as x is a number that's negative 2 or smaller, or x is a number that's 1 or bigger, then it's fine. Then we end up rooting a positive number. So for instance, negative 11 is here. Yeah, it's to the left of negative 2. It's part of the domain. So let's find f of negative 11. Okay, remember domain is the set of valid inputs. So since negative 11 is part of the domain, that's a valid input. So if it's really a valid input, it means when we find f of negative 11, that the output is going to be a real number. Let's just look at the very top line, which has f of x, and plug in a negative 11 for every x. So you have f of negative 11 equals 3 plus root in the absolute value 4 times, here's the negative 11 replacing the x, plus 2, close absolute value, minus 6. If we think about what's here in the absolute value, it's a negative 44 plus 2. So inside the absolute value, that's going to be a negative 42, but we're going to absolute value it, so we'll get a positive 42. That positive 42 minus a 6 in the radical ends up being a 36 in the radical. So we still have the 3 hanging out in front, so it's 3 plus root 36, in other words 3 plus 6, which is 9. There we go. We got a number. We got a real number. So it was fine to use negative 11 as an input. We get positive 9 as an output.